This is the Creating a Custom Civil 3D Pipe Network Parts List webinar in Civil 3D. I'm your host, Brian Tanner, Senior Technical Specialist at ATG, and today's date is March 2nd, 2021. Thank you so much for joining us today, those who are live in the webinar, as well as those who will watch the recording later. Appreciate your time, your attention, and any feedback that you can provide with regard to this webinar. While we go through the webinar itself, I encourage you to submit any questions you have through the Q&A feature within Zoom. That's obviously for those who are attending live. Feel free to reach out after the fact with any questions via the YouTube channel commenting system that this will be posted to, or my contact information is shared on the last slide before we close. I encourage those questions to come through while we're in the meeting, though, for those who are attending live. If we have time to answer all of the questions that are requested, we'll certainly try to get to those in the time allotted. If not, that's why we use the Q&A feature. We can save that information after the meeting ends, after the webinar closes. If you use the chat function, I don't believe we have the ability to recover that information. So please use the Q&A. Again, my name is Brian Tanner, Senior Civil Technical Specialist for ATG. I'm based out of Mishawaka, Indiana, which most people are going to be a little bit more familiar with South Bend, Indiana, and the University of Notre Dame, which is right where I'm next to. I'm a Civil 3D Certified Professional, Autodesk Certified Instructor, Green Road Sustainable Transportation Professional, longtime contributor to the Autodesk User Group International magazine, and I have product expertise in several different applications within the Autodesk AEC suite and collection, as well as Bluebeam Review, which we support and encourage folks to use as their markup and PDF sharing and editing software. While we dive into the subject at hand, please know that I've utilized these methods in industry for 14 years. Specifically with Civil 3D on municipal, state DOT, county, commercial, and institutional developments. So this is real world experience coming into play. We are going to talk a little bit about the part catalog as it relates to the part list, but we all know, for those who've done a deep dive into the part catalog, that is a subject in and of itself for significant and custom editing of structures and specialized components within the catalog. So we will touch on it, but we're not going to do a deep dive on the catalog itself. So what is a parts list for those who are just getting into Civil 3D? Well, Civil 3D comes with the Pipe Network part catalog, and it contains a fairly sizable library of pipe and structure options. Those are broken down by material type, shape, and size. We have box structures, concentric cylindrical structures, concentric structures with rectangular frames. We have elliptical pipes and box culverts and kind of everything in between. HDPE, PVC, corrugated metal pipe, reinforced concrete pipe, etc. So we've got a pretty robust list of options right out of our default installation of Civil 3D. The parts list allows us to break down that catalog into the types and materials of parts that we frequently use on projects. If we were to create a part list to use inside of our templates and thus our projects that consisted of all parts, sizes, materials from the catalog, we would have paralysis by analysis. There would be way too many options to select from. It would bloat your template to a point of no return. Every single X reference and file reference into other drawings would additionally bloat those files. So we create a parts list to have a curated list of pipe and structure types and sizes that apply to the type of work that we do on projects. Why a custom parts list? Well, I kind of touched on that before. We get to curate that list down a little bit. But parts list for Civil 3D networks can extend to a wild level of extremes between different organizations and how they plan to use it. I would say that some of these extremes cause issues, though. I've seen templates with no pipe or structure parts defined within them. network lists that have too few parts, that don't accommodate the material types that a firm needs to use on a given project or the sizes. And it's left to the individual Civil 3D user to add those individual parts in on each project rather than include it in the template. Sometimes there are too many parts to choose from. I mentioned that paralysis by analysis of having too many parts from the catalog in your pipe network list. That just creates problems for which part is the right part to choose at any given time or to swap parts after they've been placed. Poorly named parts. It's important to make sure that you have a discrepancy and a unique name for each part that you have inside the network. That becomes critical for an often underutilized or not even realized option that we have inside the parts list, to where we can have duplicate pipe material and part sizes in our parts list that represent different phases of a part or different styles that need to be applied to it. And if we don't name those parts uniquely to identify them separately, we could run into some issues on selecting the correct part. Poorly styled parts is an issue that I've seen in parts lists. Lack of or too restrictive of rules to the parts list and the parts within it. If you don't have the rules defined, you're missing out on some automation of your design as you lay out your pipe network. But if you have too restrictive rules, it becomes next to impossible for Civil 3D to make decisions for you as you lay out those parts, or to provide false negative warnings as you make edits to your parts as they've been laid out in your pipe network model. Also, I've seen parts that are added irregularly by material or size to where they're not in order. Uh, that may be more of a pet peeve than a serious issue, but we want people to be able to select the correct parts in a logical order inside the network layout tools. Why multiple parts lists? We may have a variety of needs, such as stage of development. Now, it is possible to create all of these within a single parts list, but different firms have different workflows and may utilize separate parts lists for each phase of development: existing, demo, proposed, or future. Again, I mentioned before on the previous slide that we can have duplicate part sizes for each material type in a given parts list. So if you had 12-inch RCP for existing, demo, proposed, and future, you also have the option of including all of those stages of development for 12-inch RCP in just a single parts list, utilizing the various styles that need to be applied and the naming conventions that need to be applied to those part descriptions. More purpose. Maybe it's sanitary, storm, or combined sewer. Living in the Midwest, we have a tremendous amount of combined sewer and CSO projects that are occurring basically every day. So we have sanitary, storm, and combined sewer projects that we work on, and we may have separate parts lists for each of those purposes. Need for a parts list also is accommodated by a custom part catalog. Again, while Civil 3D comes preloaded with a tremendous number of options for pipe materials, shapes, and sizes, there are still those extremes that aren't covered with the out-of-the-box catalog parts. I've worked on numerous projects where a significant tunnel project required the addition of larger diameter pipes than what Civil 3D was supplied with out of the box. Modifying the part catalog, however, does come with some baggage. As soon as one person within your organization creates a custom part, that part catalog and that specific part needs to be included in a new part catalog location saved to the server, accessible to all users, and then every person's workstation, specifically their version of Civil 3D, needs to be connected to that part catalog. And we'll get into that in a little bit during the demonstration. So every user will need to configure that catalog path. If not, then you run into errors. Notice the structures that have been projected into profile view in this image. That is a significant issue that occurs simply because you're not connected to the correct part catalog that was used to develop that specific part that was included in the network layout. So lack of sharing or connecting the appropriate pipe network part catalog will result in errors like this. Simply connecting to the correct part catalog, even after the fact, updating the drawing will resolve that issue for you. So it's a simple fix, but it's a key indication that a custom part has been used that did not exist in the default part catalog that came installed with Civil 3D. And that information needs to be shared on the network for everybody else to connect to. Now, let's head into a demonstration using these tools. So we're in Civil 3D, it's a base drawing project, fairly simple one, but we're not here to mince words over the exact design. We're here about developing a template that is purposeful and contains a parts list that works for us. Now, let's dive first into the parts list itself. You saw a tab that may have been open there right away. We do have some parts in here that we could select. I could select any structure or pipe, and it'll bring me to the contextual ribbon inside Civil 3D that I could access the parts list dropdown. However, if you're working in a blank, empty template and you're building it out for your organization, you're not going to have a single structure or pipe to select. So the quick way to access that parts list is to go to the Modify tab of the ribbon, select the pipe network option from the design panel, and that brings you into what is essentially a static version of the contextual ribbon for pipe networks. Now from the parts list dropdown, we can look at and evaluate what exists inside of our current parts list. Again, if it's straight out of the box, this is going to be fairly simple, but let's explore for a moment. We will select the parts list. Let's just look at Storm for the time being. A lot of people are inclined to hit OK once they get to this point. You're going to the parts list, you're selecting from a dropdown, and you select OK. That actually just switches you to that parts list temporarily. It does nothing. You're not editing or viewing that parts list. We have to edit parts list, select it from the dropdown, and actually choose the edit icon to the right. There's a dropdown to where if we needed to duplicate or create a new parts list, we can, but the default is always going to be this pencil and brush icon for editing your current selection. That's what we want. That's what brings up our window for editing and managing our current parts list. So information tab, pretty straightforward and simple. Obvious name, description if you need it. We have a pipes tab, a structures tab, and then obviously a summary for everything that's included in our parts list. But let's talk a little bit more about the pipes tab first. By default, you may have a very simple parts list. I think out of the box, a completely untouched file from Civil 3D is going to load by default PVC pipes and maybe just a few options within that list of materials. If we need to add additional pipe sizes or additional material types, we have two different methods for doing so. If we right click on the network parts list name at the top, in this case Storm, and we right click it and choose add part family, we'll see the various material types and shapes that are available to us inside of Civil 3D. It's a very basic graphic preview, but it gives us an idea of what to expect out of the pipes that are being added inside the software. So if you needed an elliptical pipe, or you needed a rectangular box culvert, or a different material type in your circular pipes, we can select one or multiple material types that could ultimately be added. I may have culverts on this project that are composed of CMP, so I may select that. And perhaps I have some crossings that are near water, and to adhere to 10 states rule, I may have some ductile iron pipe that I use for storm projects as well. Again, you're going to build this list out to meet your needs, not just on this project, but you're going to add this back to your template so it accommodates all of your projects. But again, you don't want bloat, you don't want excess. Looking at the material families, the part families that were added, note that there's only a plus sign next to a concrete pipe that was already loaded into our parts list. I need to look and add additional information into my CMP and my DIP to include additional part sizes or new part sizes at all. If I right click on any of those material family types, I can select add part size. And then I can see from a drop-down list, selecting in the pipe diameter cell, what part sizes are available to me. Now, the inclination for a lot of folks is to utilize this column to the right that says add all sizes. And you're not necessarily wrong for thinking that. If you do in fact anticipate that you will have a very large variety of pipes diameters to be used in your projects, you can absolutely choose to add all sizes and select OK. Expand the material list, and you'll see that all of those pipe sizes have been added. The problem that I run into with firms is they'll do this. They'll find some less than common pipe sizes, right click and remove it to try to streamline their parts list to remove some of the less common sizes. But some of these large diameter pipes aren't used very commonly either, and they leave them in. Then they find out later on, oh, we do need a 42-inch pipe. We do need a 78-inch pipe. They right click, add part sizes, and they add those two pipe diameters in. But, and this is again one of my larger annoyances within the software, those are added to the end of the list. There's no way to reorder this list inside the parts list. We can't just drag and drop or move this up higher. So our only recourse is to remove the pipe sizes that are larger than the newest one that you placed, except we can't shift select, right click and delete those. Notice our options are limited. We can copy those to the clipboard. We could try to delete. It just doesn't work that way. We have to manually remove each pipe size that is larger than the smallest one that we just added to our list. And you can see that it becomes a tedious endeavor to individually delete each of those to reorganize the parts list. So I'll save you the time of doing that here in the CMP pipe, just to note that that is a tedious process. I'm not blaming Autodesk for that. It's technically been that way for over a decade, and we should know better by now. Or for us new users watching this for the first time, now you know. Now you can prevent yourself from running into that issue. So what would I do? I would right click my part sizes and I would add in the sizes that I want or just all the sizes and stay away from removing anything from the middle. So as long as you avoid removing anything from the middle with the opportunity to have to add those back in later, just build out the full list and be done with it, or just add in the smallest sizes that you know you need with the opportunity for somebody to add the other sizes in later, preventing you from having any issues. I would argue that in this corrugated metal pipe list that I created, it would be faster to simply delete the entire family, add it back in, and then re-add the specified part sizes than to one by one individually modify that parts list to reorder those parts. So please keep that in mind. Though the one exception to that rule is if you take your parts list to the next level, which is what I would encourage. We have concrete pipes. If I need to add additional pipe sizes above 24-inch, then I could add those in individually, or it recognizes that 12, 15, 18, 21, and 24-inch pipes are already a part of this list. I can choose to add all sizes if I truly want all sizes. Select OK, and it just adds on to that list. It does not automatically duplicate any of those sizes. But once we have the appropriate list of pipe sizes that we want to use inside of our parts list, that's when I go back through and I start to rename all of the parts exactly how I want them labeled inside my plan, profile, and section labels. By providing an appropriate description within our parts list, we make our life a lot easier for automating the process of labeling these features inside our plans. So if this is simply a 12-inch RCP, then we can end there. And you define whether it's storm or sanitary within the line type or the layer that it's on. But perhaps you include storm or STM for storm as an abbreviation within your set. And I would encourage you to go through this process for each part that's in your list. Again, replicating exactly how you would label it on those projects. The key here is that you're not doing this on every single drawing, on every single project. You're doing it once in your template, and you're saving everybody else time on every project that they work on to automate this process. They don't have to worry about it. It's already there and available for their use. But we also do have the option, like I mentioned before, of defining these by phase. Perhaps you have a 12, 15, and 18-inch RCP storm that's existing. And maybe it's, again, you might want this to be labeled explicitly within your parts list, because we do have the ability to add, again, individually, additional 12, 15, and 18-inch parts, which may seem like a duplication, but this may be a 12-inch RCP storm proposed. Again, some of this can be identified and easily handled within the styling and the particular labels that we're using. But we want to also make sure that we are discreetly naming our objects based on how we want them labeled within the plans, as well as making it easy to select the correct type part within our layout tools. So in this context, we may have two different styles to be applied, especially if we have smaller diameter pipe and larger diameter pipe. We may have existing and proposed that needs to be applied to everything. I may need to create, in this particular example, a new style for existing. And I'll do this rather quickly. I won't even adhere to any of the display settings, simply because that's not what we're here for, is style creation. But if we have a separate existing style that was styled with the appropriate layer and line type, we could quickly apply that to just those existing storm objects. Again, why would we model the existing information? Well, you may have a singular network that represents your proposed project flowing into existing. It may include demo. It may include future. And on many projects, we're expected to analyze that entire network, whether you're using storm and sanitary analysis or hydroflow or any other tool. We need to make sure that the entire network has connectivity, and providing a parts list that accommodates that connectivity and the associated styles. You can create separate part types that reflect the specific styles that you would have applied. Yes, we can use a single part type and just simply apply different styles. But if you need to have it labeled differently in your plans, we've already accounted for that within the part name. We already are automating the part labeling using that information, and it speeds up all the work that we do inside of Civil 3D. All right, what about rules? Within our parts list, it's not complete unless we set up our rules to be applied. Now, the file that I'm using right now just has a basic ATG rule set. I would argue that you probably are going to have a different rule set for storm versus sanitary, that we would want to name that appropriately. So this is our storm rule set. The rules themselves, we have three basic rules. This may be all you need, but we have cover and slope that maintains the maximum and minimum cover to be applied to our storm network, minimum and maximum slopes to be allowed as we lay out the pipes. Again, automating that process, allowing Civil 3D to make some basic design decisions for us as we're laying it out. Applying maximum length checks. This is why I have many templates that I've created with two different rule sets for storm, because if you've got a smaller diameter pipe, you may have a rule set for small diameter pipe for the length between structures that's allowable for maintenance purposes. And then larger diameter pipes that have a much greater span between structures that's allowable for maintenance. And then match locations. We have additional rules that can be applied such as pipe to pipe match, which is located there, or simply pipe end location at structures. So the pipe end location at structures, we need to make sure it matches how we intend to model and label our pipes as well. I know most firms either model and label from either structure center to structure center or structure inner wall to inner wall. We just need to make sure that the rule set matches what we intend to use for our label styles as well. We don't want to have a modeling discrepancy between how our model is drawn versus how it's labeled, because then our users are going to have some level of confusion between what their properties for every pipe and every structure shows versus what the labels and our set of production plans displays. Okay. And many firms stop there. We have styles applied. We have appropriate naming conventions applied. We have a little bit more robust list of material types and sizes and their specified uses within the set, as well as maybe we take it to the next level of applying render materials that are to be utilized for um, 3D modeling and rendering it in a software like 3D Max, 3ds Max, or InfraWorks, and automatically porting this render material over to those software packages. And then lastly, pay item information. So depending on your state DOT or your jurisdiction's pay item list and the availability of it, or your willingness to map those pay item IDs to your various parts lists, we can actually build that out. So we can load master pay item list. There's some default out of the box ones that are available to us, but we definitely have state to state options that are available. Many states have at least a PDF that you can convert to an Excel spreadsheet that can be loaded inside of Civil 3D. So I believe we have some basic categories that I can load just to get started and show you what this looks like. So we have different divisions that are created. And if I'm looking at, I may have loaded a specific pay item list and categorization file that does not include pipe networks specifically, or I'm just overlooking it. In either case, those Excel spreadsheets can be built out. The pay item ID for each item could be noted and applied to each of the items in your pay item list for the pipe network parts list, so that whenever the parts list is completed, your project is laid out, you can quickly export a QTO file representing not just the amount of pipe used, the number of structures and sizes of structures used, but the costs associated with each of those. All right, let's move on quickly to structures. We have part families for a variety of structure types, inlets and outlets. Think of your end walls and flared end sections and things of that nature. Junction structures with frames, so our manholes, whether it's concentric or eccentric, whether it has a circular or rectangular structure, and then the frame shape itself. We have a pretty extensive library here. This covers 99% of your needs. I do know that there's a desire, and some have created custom parts for trench drains and things of that nature. And again, that's a different subject for a different webinar. I know there's some content out there about that, and I've certainly created my fair share of custom structures. But here we go. We're covering 90% of your needs, whether it be a manhole or an inlet structure, whether it has a frame or not, its shape, as well as its purpose. So we can add any of those. Let's see, concentric cylindrical structure. We currently have, I'll just add an eccentric with a rectangular frame and a few others just to identify what parts list capabilities we have within there. We do have to note that we have a variety of additional sizes that are up for consideration for structures compared to pipes. Pipes have a little bit more strict or consistent standards across them. A pipe of a given material and inside diameter is going to have a very well-defined thickness for the wall. Whereas structures can accommodate whatever our needs are on a given project. We may have an inner diameter of a structure that we want all part sizes to be added, but not necessarily all wall thicknesses or floor thickness options. But we can add that parts list in define all those default wall thicknesses and kind of build it out from there. Again, this can be as little or as great as you need it to be, but this is where our part naming comes back into play. Concentric structure, 48-inch diameter. You're probably just going to call this a 48-inch DIA or whatever your abbreviation is for diameter manhole or 4-foot manhole or however you name it and label it on a set of plans. If you do list that additional concentric or eccentric or frame information, we can do so. If you want to automatically build out a library of structures that meets your casting needs, and you list those castings consistently on your labels for structures, this may be a 48-inch diameter manhole with NINA R-1660. Don't blame me if that's not a real Nina casting. I'm just pulling something out of thin air here. But we could build out a structure type with that name and the associated style, come back in to add a part size, 48-inch, with the same wall thicknesses and everything. But perhaps instead of just a regular street drain, perhaps we have an additional 48-inch manhole. If I can edit my text a little bit easier, there we go, 48-inch DIA manhole with NINA R1720 or whatever the case may be. We have that ability to simply duplicate the part, create the description that we want to have it labeled in the set of plans, build out the library as extensively as we use on our local projects or our DOT projects, and then apply the appropriate styles. So these are all store manholes. Apply that appropriate style to it, but it's going to be labeled the way that I placed it within the part description. Again, the rules apply to structures similarly to pipes. It's just a different level of information that's included. The drop across the pipe, the maximum pipe size that can come into a 48-inch diameter structure, things of that nature. We can add additional rules, but it's a little bit more limited for structures than it is for pipes. Maximum pipe size, pipe drop across structure, and sump depth if applicable. Again, build out the list to as little or as great as you need. Apply the appropriate style, rule, render material if you plan on bringing this out to a 3D modeling software for rendering purposes. Pay items if you have any, and then the structure types if you include that within your modeling and drainage configurations. This is a critical part for making sure that the mapping between Civil 3D and SSA is handled appropriately. So we need to make sure that we configure this aspect of our templates as well for that mapping between the two analysis softwares. Okay, pipes, structures. Let's assume that we've built out the library to the extent that we need for our template. Obviously, that's not done within the 30 or so minutes that I've been talking about it, but it takes some time. It's iterative. You only do it once and you do it within your template. But then you run into an issue. You know that you have a project either regularly or coming up that needs a larger pipe diameter size than what you have available out of the box. Let's say you have a CMP culvert out in the country that's going to be larger than a 12-foot diameter. Unlikely, but hey, everything's possible. It may be a concrete pipe rather than corrugated pipe, but if I right click and go to add part size, you'll see that while our list is extensive, we don't have any ability inside the part size creator to add new part sizes. We just can't do it. We can select from the available options, but that's just what's available out of the box through our part catalog. So we have our network parts list and it's complete except for those one or two custom sizes that aren't available to us. I've actually run into this a few times with folks or jurisdictions that have 8-inch RCP. And we just don't have that out of the box, or a 14-foot diameter RCP tunnel. So we have to click OK and save the changes that we've made to our parts list, but we need to modify our part catalog. First and foremost, we need to see where our part catalog is pathed to. By default, if we go to that parts list drop down on the Pipe Networks ribbon, we can go to Set Network Catalog and see that out of the box, it's at a standard saved location on our C drive through program data, Autodesk, Civil 3D, whatever your version is, and then narrow it down to the pipe catalog folder. I'm going to jump out of this really quick because I promise you, you really don't want to edit this location on the C drive. If you're going to make modifications, you need to share it with your team. And to share it with our team, we need to do that through copying our pipe catalog to another location on the server. So what I've done already, because I'm on a VPN to our server, and it would take just a few minutes to do that, I didn't want to waste in our training, is I navigated to where that C drive location is of the pipe catalog straight out of the box for Civil 3D. Backed up a level, I right click copied and pasted that into a network drive location that I and everybody on my team can access in the future. So there's our pipes catalog on our V drive compared to the C drive location inside of Civil 3D. Great. What's inside that pipe catalog? Well, we've got metric pipes, we've got imperial pipes, and we've got other drainage content that Civil 3D references. Inside each of those subfolders, we have additional subfolders for each part family and material type, associated XML files for the tables for all those sizes, et cetera, et cetera, et cetera. Now, you're not going to likely modify those XML files. You're capable of it. If you're comfortable with it, you can do so. But what most people are a little bit more comfortable with, and what I'm going to display through this webinar, is we go to the parts list and we set our network catalog location from our C drive location to our shared network location that everybody on our team can access and needs to connect to for their use of any project in the future that connects to or utilizes any of these custom parts. So I select the pipe catalog folder, select open, let it load for a second because sometimes, yep, there you go. It likes to default to the metric catalog. If you hit OK too fast, you don't realize that that's happened. So we go to the dropdown and make sure that if you're in the US, you're almost assuredly using the US Imperial Pipe and Structure catalogs. So selecting OK. And now I'm connected to those pipe catalog parts lists on the server. If I go to edit that parts list and go to Storm again and edit it and add part sizes, you can see I'm gonna have the exact same sizes that I did before. Actually, there is one custom part there that I did in a previous class, but let's ignore that. Everything else here is duplicated. 162 was not available outside of the box. For illustrative purposes, I'm going to create yet another part size, maybe a 8-inch or a 10-inch RCP, just to illustrate how this process works and to not pull any smoke and mirrors. So we'll go to OK, close out of here because we didn't make any actual edits. And I need to go to my part builder. Now, don't go to the part builder whenever you're connected to the C drive location. You do that, you're modifying the out of the box file. Don't corrupt anything that came installed with Civil 3D. Always create a duplicate, make yourself a backup of that original file so that if anything does get corrupted, you can recover the original information. But we go to the part builder as it relates to our server location, connect to the particular pipe type or structure type that we want to create an additional pipe size option for. Make sure it's the correct material type and shape as well, and then modify the part sizes. That'll open up a different window for a part builder. And as we get into that part builder, you can see some of the parameters. This is not all that different than dynamic blocks and some of the parametric design that's built into those, but it's specific to the parts that we use within our pipe network modeling. I'm going to right click any one of my size parameters and choose edit. Come down to the bottom of my list. We see that one custom part size 162 that I had done in a previous demonstration of this. And I'll just create a new part size. I could have modified and just overwritten that one, but I'll make this an 8-inch pipe inside diameter. And you can kind of interpret what these columns mean. Pipe inside diameter, wall thickness, Manning's coefficient, material type, part size name, things of that nature. So If we expand each of those columns, which can sometimes be tricky depending on your mouse sensitivity, we can start to see what builds out here. Now, if you want to get really tricky, you can modify the part size name inside of your custom part catalog so that whenever those parts are ever added to your template or through to your parts list in your file, that they automatically come in with the part size name that you intend to have them labeled as in your plans. So it reduces even one more step of renaming inside the software if you do it once within your part catalog list. So we have an 8-inch pipe that we'll assume has a 1.75-inch wall thickness. Material's going to have a consistent Manning's coefficient, and we can see the default naming structure just adds the inch concrete pipe behind whatever diameter that we chose. I'll select OK. And then I will close out of this dialog. You can save beforehand, but I know I'm going to get prompted to save my changes. Select yes. It'll take just a second because it's writing these changes to the network drive location, which I'm currently connected to via VPN. You're directly connected to your network drive. It's just a little bit faster than that. Now with that custom part size available inside of Civil 3D, I can go to my parts list, edit the parts list, and that new pipe size is going to be available to me as I add part sizes. Now, it's always going to be out of order in the dropdown here. And I'm pretty OCD and finicky about this. I would probably remove every single pipe definition that's already in my parts list and replace it so that I can place these in the correct order. Because the order that you see it in this list within the part size creator is irrelevant. That affects nothing within your drawing. However, the order that we see it in this list directly in our pipe network parts list is the order it will display inside of Civil 3D for our actual layout selection, our drop down for those pipe sizes. So while I may call this 8-inch RCP storm existing and apply the correct style, I would never in a normal template that I expect other people to have to utilize, let this sit at the bottom of the list. I would take the time to reorganize it, select OK, because whenever I go to edit my pipe network, give it a second to bring up my layout toolbar. Now my 8-inch pipe is at the bottom of the list instead of at the top. Now it's critical, and I mentioned this when we were going over the slides originally. It's critical that as soon as I have that custom part inside my set of plans, inside my drawing, that every other person that will ever touch this drawing at all will need to have that parts list, specifically the network catalog, tagged to that same network drive location. Without that, they will run into those errors that I showed before, the errors as they reside to specifically projecting things into profile view and cross-section views. Another thing that is critical, I believe this is my storm network, and if I select that pipe, it's, yep, it's a 12-inch pipe. Looking at that pipe and looking at the, I believe that was also the RCP. It's a concrete pipe, 1 foot diameter, 12-inch pipe. But if I go to my parts list and edit my parts list, you'll see that I don't have anything named that way anymore. Go to the storm parts list. If I look at my concrete pipe, my 12-inch diameter pipe it's not using that same name structure that we saw in the drawing. There's an interesting workflow process inside of Civil 3D that it anticipates and expects that you're not going to build out your pipe network until you already have a parts list defined. So that whenever you place your pipes and your structures, it's going to be placed with the correct style, the correct name, correct description, and everything else. We can certainly swap parts if we made a design decision that needs to be changed. But if you go back into your parts list and rename anything or add additional pipes and duplicate styles for individual parts, we do need to go back and we need to actually swap that part. So we have a 12-inch diameter pipe that was produced before we renamed the parts list. We actually have to swap that part for the exact same part inside the software in order to go to the properties and see that the information has in fact been updated. So that is one key aspect. If you do make any modifications to your parts list after that same pipe or structure type has been added into your drawing, we have to go back and swap the part, even if it's the exact same type of part, the exact same material and diameter. We do need to swap those parts to make sure that there's consistency in our naming, consistency in all of the pipes and structures that are included in the set of plans. Now, with that said, that's the gist of creating those custom pipe network parts list, especially whenever it comes to working with other individuals on your team when you have custom parts as part of your catalog. So I'm going to go ahead and switch over to let's see, questions, and I may have to jump back and forth a little bit. I do see that we have one question. Do you know whether or not the 2022 version will change any of the catalog files or formats? I would hate to make all of these changes and not be able to copy it to the 2022 version. Dan, thanks for that question. It's a great question, and I'm hesitant to respond to it because I am part of the beta program for Autodesk and for Civil 3D specifically. And you know, they call it the futures portal for a reason. We sign a non-disclosure agreement on what's coming. I do know that we are very close to an announcement on 2022 releases, and you won't have to wait long for that answer. So I'm not trying to scapegoat out of responding to you. Thank you very much for the question, but I'm hesitant to respond with regard to what I know and can, or what I know and I cannot share publicly. So you're going to get your answer very, very soon. That's the best I can do right now without potentially putting any kind of issues into my NDA, my non-disclosure agreement for that Autodesk Futures portal. Any other questions that folks have, please go ahead and filter those into the Q&A section. I'm more than happy to respond to them. I'm going to hang tight for a couple of minutes while you have the opportunity to do so. That may be just a general question. It may be a question regarding anything that I've shown specifically, or if there was something regarding parts lists and part catalogs that you did not get to see, I'm more than happy to show that over the course of roughly the next 9 to 10 minutes that we have time scheduled together. And if we don't have any further questions after a few minutes, then I will likely go ahead and close the session and then encourage you to respond and reach out outside of this particular webinar with any questions you have in the future. So again, Dan, thanks for that question. As I wait for others to chime in, it's a very legitimate question that I wish I could answer. I'll just say I think you'll be happy with the results. I'll keep it that vague. With whatever's happening with the 2022 release, I think you'll be happy with it. Joel, thank you for that question. Can you speak to the advantages or disadvantages of separate networks versus one combined network for existing and proposed pipes and structures, slash labels analysis, etc.? So I'm a big proponent of having a single network for storm or sanitary, connecting your existing and your proposed, because our projects may be limited in scope, but they have an impact on all the surrounding networks that we're tying into. So when a surveyor goes out and picks up the existing network, they're usually going a couple structures further downstream or upstream in all directions so that we can capture what the inflow and outflow of our network is. And if we need to analyze that as part of our network to provide those results for 10-year, 50-year, 100-year storms to our clients, then they need to be a part of the same network. And if they're a part of the same network, then we need to account for that within the styles that we use. So I'm a big fan of doing a singular network for existing and proposed for Storm. Um, you do have the ability to do them as separate networks. I certainly know firms that don't model the existing network at all. They just draw manual line work and profile views and things of that nature, or just their survey line work. It gets projected. Um, but I think that's only answering half the question, and it leaves a lot of unanswered questions whenever it comes to the analysis. It also creates additional work because while it may take some investment of time and effort at the beginning of a project to model that existing network, you get the benefit of Civil 3D projecting it into your existing and proposed profile views and cross-section views rather than having to manually add that line work in after the fact, as well as label it. Matt, are eccentric reducers available in default parts lists? So I think whenever you're talking about reducers, you're talking about inline for the pipes themselves. And from you can build in some pipe to pipe connections that are not like sizes, but I am not aware of any custom or out of the box certainly inline reducers for pipes in the catalog. Um, I suppose it is possible, given the parametric options inside the part builder, to provide an eccentric reducer. I've never had a need for that. Certainly we have eccentric tools for structures, um, and we have a variety of sizes that are available for that. Um, we could develop a structure style that ultimately replicated a eccentric pipe as far as the pipe to pipe connection, and utilize a custom structure type for that purpose, but not the pipes themselves, certainly not out of the box. Um, and I appreciate that, the thank you from folks in the Q&A. I appreciate your time today. Um, I think that's really about all the time that we have together. If you have additional questions, I'd encourage you to reach out, stay connected to ATG on our social media pages. Certainly within LinkedIn, we share posts and updates about webinars just like this on a weekly basis that we promote and produce. Many weeks we have multiple webinars that are available to you for free. I hope you gain some value out of this and you're able to apply some of these tools and this knowledge to your template and your daily workflow. Certainly tune into our YouTube channel as this video and others just like it are recorded and then uploaded to YouTube within a day or two after we've completed the live webinar. And with that in mind, I thank you again for your time. I believe those who are attending live with us, you'll be prompted with a very brief survey that'll appear after the webinar ends. I'd encourage you and appreciate if you could take the time to fill that out. And any of those who are watching the recording or live, my contact information is at the bottom of this slide. Feel free to connect on LinkedIn. I share information about these videos, not just for myself, but other members of our Team Dirt here at ATG, our civil team, as well as some really great resources and tools that we provide with regard to other supporting software like Bluebeam, BIM 360, et cetera. Thanks so much again, and enjoy the rest of your day.